Hello everybody and welcome back to my channel. Today I am going to describe about the topic known as the integration by parts. So I personally think that most of you must have seen multiple videos on this topic, but I think today you are going to learn something new and very interesting in this topic, that is how to derive it at first. How to derive the theorem, that is a written proof of for the bypass method. I will be showing the proof, then I will be doing some questions on it. So let's get started. And before that, I would like to mention this formula. This formula you must have seen in your books. So I will be just mentioning this once more. The first function multiplies the second function. This is known as the composite function of two functions, right? So how can we integrate it with respect to dx? So we'll be writing, this is a common notion to write first function multiply integration of second minus whole integration of ddx of first multiply integration of second whole dx integration, right? So how this came? So today I will do the proof and try to do it in the manner it is meant to be. So let's see. Well, so here's the proof. So first step, let us take function f of 1x as ux, right? So this is just a variable, think it about. And second function f of 2 of x is integration of v of fx, right? Well, so let's look further into it. So then I will be having the composite function of it, right? The so-called this function I want to see the integration, right? But as you know, and if you don't know it even, you can see my previous video where I elaborated on this topic, that a function can be traced back to its curve and as well as its slope with the help of anti-integration or derivative, or anti-derivative and integration, right? This symbol I have described in my prior video. I will give a card to the link in the upper corner of the screen, or you can see in my channel. But let's now move forward. So as I told that both of them are the two sides of the same coin, so let's try to flip it and see the probability of getting this from this, right? So what I am trying to say here is, I will be having the derivative sense at first, then I will try to reach to the integration sense. So when I will be doing, you will see what I am trying to say. So I am taking this composite function, then trying to derive it, right, with respect to x, right? So what is going to happen? First derivative multiply second plus second derivative multiply with first, right? This is the basic notion. This is known as Leibniz rule. I hope you are well accustomed to this very notion. So by taking that in account, I will be integrating on both sides, right? Just integrating on both sides with respect to dx. Actually, you cannot integrate anything without giving a small portion of, infamously small of that very axis, or how else you are just taking the curve of the slope that is given to you. Nonetheless, you don't have its elemented portion. Nonetheless, let's talk further, right? So here you can see the thing get cancelled. It is not right to do in this way, but I am showing in a graphical manner. So this becomes what? F of 1 of x multiply f of 2 of x, right? This only this side, write it or imply sign always the RHS, and then equal to this whole thing. And as you can see, here is the tricky portion. You are seeing one derivative is there and one function is there, right? And here I mentioned the function is a function, whereas this function is an integratable function. This is where the main trick in the proof is. So let's do it further. So just dividing the upper integration in two parts, let's see what happens. Just algebraically differentiating both of them. I'm doing nothing else, just algebraically differentiating both of them. So you can see they are quite the same. Now here you can see an very interesting thing. What is the very interesting thing? Well, right up to this, I think you have wrote in your copies. So I'll be rubbing up to here. I hope you have wrote, and now I'll be rubbing, right? Well, I have wrote the last line up, and here I have wrote the things that I took as assumption. Can you see a pattern right here? Well, I am showing you the pattern right here. What I am trying to say by this. By this, what I mean, I am trying to say. See this closely. What I am writing right here. Well, see here what I am writing. That I'm just rearranging the stuffs that are written already, right? Just rearranging and doing nothing else. I hope now you can see a clear thing what I am trying to say. Here see, f of 2x is the integration form of v of x. So can I write the differentiation form as v of x? It is well legit to write, right? Yes, it is very legit to write. So I'll be just substituting these values and here, and you will see you have already derived the we have already derived the Bypass theorem right here in front of our eyes. Here f of x is u of x, writing, substituting. Differentiable form is v of x, substituting, and just substituting and doing nothing else. F of x, f1 of x is what? U of x. I'm just substituting and doing nothing. F of 2, this version. This is integration of v of x dx, right? And this is a subtraction sign right there. Noting it down, whole integration, right? Whole integration using the symbol. And s stock 1, that is this differentiation, right? So how to write? du of x, differentiation with respect to x, and f of 2, that is the integration format, right? So v of x dot dx whole dx integration. We have already achieved our the format. So let me write it properly one more time, the last line. Up to here I hope you have written. If not, write it in your copies, or I hope you have understood up to this portion. So I am rubbing this and writing it in a better way, so you will be understood in a better way. Well, for your better understanding, I have wrote it one more time. So here you can see the rearranged format. I have wrote it once, then again I have wrote the values that I pre-assumed, then just by substituting those values in that upper format I got that. See how? Check this. F of 1 of x equal to u of x. F of 1 of x, u of x, right? If differentiable format is v of x, right? This side format, that composite function integration, equal to f of 1 of x, ux, f of 2 of x, integration format of v of x dx, minus whole integration of f of 1x, derivative sign, that derivative sign of u of x of in order with dx derivative is done, then f of 2x, the integration format of v of x, whole integration. This is the very integration by parts. So I hope you understood this very topic, and I hope you enjoyed this video. If you did, so make sure to subscribe the channel, share it with your friends. Well, I thought I will be doing one more question so that the lecture could be fulfilled in a good way, completed in a good way. So let's do one bonus question right here. I would like to call this an intermediate question, not a very hard question, but mostly when I was a student of class 12, I used to misinterpret this as a substitution based question, but really this is there is no substitution. Even if that will take you longer than by using the by parts method. Now you say, why is by parts method? I can see only one function, this function, log function. Very right you are. There is only one log function, but there is always one in front of something that is multiplied. And I hope in your books you have read about the eyelet. If did not, I am telling you about this. This is a format. This is no specific theory or anything. Like 90 to 95% cases will be fulfilled with this of by parts integration. Very less like special cases like sin x by x. These are known as loop questions. You cannot do with them. But if you reverse the questions, reverse the loop, or the reverse, just don't follow this eyelet, it will be solved easily. They are known as loop questions. They will not come in your CBSE board or something, those type of questions. These are higher study based questions. Many are there, such like gamma functions, beta functions and all, but you just need to know this. This is also an elementary question of higher classes, but let's not get into that deep. Let's ask what is eyelet, right? First is inverse trigonometry, inverse trig. This will get the highest priority. Then logarithmic scales, log-base functions. Then arithmetic will get the priority. Then trigonometry will get priority, true trigonometry, rather circular trigonometry. In higher studies, it is known as circular trigonometry. This is known as arc trigonometry, inverse trigonometry. Then there are various names you can check in net, and this is exponential. So exponential will be treated least priorly, then trigonometry, then arithmetic, then logarithm, and inverse trigonometry has the highest priority, right? Whenever you see inverse trigonometry in a composite function, you will treat it the highest order priority ever. Then 90 to 95% of the questions of by parts will be easily solved, except for those loop questions. I don't think they will come in your exams. But then also, just for an information purpose, that was being told to. Well, let's try to solve this, right? I hope you understood this topic well. Well, as you can see right here, I wrote the eyelet format, and that I prior made you understood about the priority topics of eyelet. So here you can see logarithmic scale and arithmetic scale, right? So I marked the logarithmic as 1 and arithmetic as 2. And this is the basic function. You will be learning the thing. You already learned the thing. I have did the proof, but this is the like you can say practical approach of the mathematical question. That was the prior theoretical approach of the mathematical question. That is known as theorem. This is known as questions and answers with some postulates or something, you can say like that. This is the rules. Eyelet is a rule, you can say, and this is a syntax, you can say, as a code. If some of you are well known to coding, then you must know there are some syntax of the code. You can think quite like the code. This is the code and that is the syntax. You need to follow this in order to run the code in a proper way, right? I hope I made myself very clear. Let's start the mathematics, right? So let's see how to write log x dx minus whole integration of ddx of log x, right? Whole integration of ddx multiply whole integration ddx, right? So first multiply integration of second minus whole integration of ddx of first multiply integration of second whole dx integration, right? So this is the basic thing that I have written in the proper, and now you can see easily it can be done. And what is happening here, this becomes x, right? This also becomes x, this becomes 1 by x, you must know it. So this becomes 1, and this again whole integration will become x. This whole is equal to x, right? So this is x multiply log x, right? This at first x log base ex minus of x. This is your answer. The indefinite sense of integration as by parts. If it would have been given like the upper and lower bounds to it, and we define the sequence, whether it converges or diverges in your higher classes you will read if you opt for mathematics and mathematics related subjects, then you will know. And if you put a value of 1 to n, this will upturn into Starling's formula, right? Given that the x is n factorial, right? So those are the different aspects. So this was the bonus question from my side. So I hope you thoroughly enjoyed the video. If you did, make sure to like, share and subscribe the channel and share it with your friends. Thank you for watching. I'll see you in the next video.